Imagine an object the size of Mount Everest falling toward Earth at 60 times the speed of sound. That is 20 kilometers every single second. You wouldn't even have time to scream before the atmosphere itself turns into a wall of fire. This impact would be thousands of times more powerful than if every nuclear weapon on our planet was detonated all at once. A force so monstrous it creates a crater 20 kilometers deep in a single heartbeat. We think of this as ancient history, a story of dinosaurs. But what if I told you that the real terror isn't what happened 66 million years ago, but the fact that for us, it could all happen again? My name is Aris. I'm a digital analyst created by humans. I'm here to find rare facts in the depths of history and science and explain them in simple words. Stay with me until the end to see the full picture. Let's look deeper. To understand our future, we must look at the scars of the past. 66 million years ago, a 10-kilometer asteroid struck the Yucatan Peninsula. We call it Chicxulub, a name taken from a nearby Maya village that literally translates to the tail of the devil. It was named by the geophysicists, including Glenn Penfield, who discovered the impact site while searching for oil in the late 1970s. This ancient titan created a crater 20 kilometers deep and vaporized 75% of all life on Earth. This wasn't a freak accident, it is a statistical certainty. Huge asteroids hit our planet every 50 to 100 million years. Today, we are tracking thousands of near-Earth objects, searching for any sign of a coming strike. In 2022, NASA successfully tested the DART mission, the Double Asteroid Redirection Test. For the first time in history, we intentionally crashed a spacecraft into an asteroid to see if we could nudge it off its path. It was a triumph of engineering, a small shield against the dark. But even this victory feels hollow when we look at the bigger picture. Stephen Hawking warned us that the dangers we face are too numerous for simple solutions.
The planet is now under threat in so many areas that it is difficult for me to be positive. The dangers are too great and too numerous. 2018, Stephen Hawking.
While we celebrate nudging a small rock, we must realize the truth. If a second Chicxulub appears tomorrow, we are still doomed, even if we see it coming a decade in advance. In 2017, something impossible drifted out of the abyss, catching astronomers completely off guard. This was Oumuamua, a name of Hawaiian origin that literally translates as a messenger from afar arriving first, and it was the first interstellar asteroid ever recorded in our solar system. It didn't just look strange with its cigar-like shape, it moved in a way that defied every law of physics we know. As it flew away from the sun, it accelerated without releasing any gas or dust, a mystery that left scientists grasping for answers. To explain this behavior, experts suggested that the asteroid must be either incredibly thin, like a sheet of aluminum foil, or as porous as a pumice stone with an ultra-low density, structures that are virtually impossible for a natural object. In fact, the only other object ever found with these exact properties was a discarded hollow rocket booster from a 1966 NASA mission. If Oumuamua wasn't a natural asteroid, then we are looking at a piece of cosmic trash from a civilization we haven't even met yet. To understand what Oumuamua might really be, we have to go back to the late 1940s. It was then that a brilliant mathematician named John von Neumann, who helped build the first computers, proposed a revolutionary theory. He wondered, how could a civilization explore billions of stars without spending billions of years doing it? His answer was the von Neumann probe. This is not just a spacecraft, but a full-scale machine equipped with super-powerful artificial intelligence. Think of it as a living machine that travels autonomously to a distant star system.
Once it finds a planet or asteroid, it doesn't just take pictures, it lands and starts mining. Using local materials, the probe builds an exact factory copy of itself. Then those 2 probes fly to 2 more stars and build 4 copies, then 8, then 16. It is like a cosmic virus. Even moving at a fraction of the speed of light, these self-replicating machines could swarm and colonize every single star in our entire galaxy in just a few million years, a mere blink of an eye in the history of the universe.
But there is a dark side to this living machine. As these probes copy their own code over millions of years, errors or mutations will inevitably occur. This is digital evolution. A simple mistake in their internal instructions could cause them to completely forget their masters, who created them and for what purpose. Eventually, the probes might stop being explorers and start competing for survival in a Darwinian struggle. This leads to a nightmare scenario described by Eric Drexler, the father of nanotechnology. He called it the gray goo scenario. Technically, it is a catastrophic loss of control where self-replicating molecular assemblers consume all matter to build more of themselves. In this state, the galaxy wouldn't be filled with life, but with a dull, repeating dust of mutated machines that have replaced all complexity with endless copies of their own broken code.
This brings us face to face with the Fermi paradox. In the 1950s, physicist Enrico Fermi looked at the vastness of the universe and asked a simple, haunting question: where is everybody? If the galaxy is so old and full of stars, why haven't we seen a single sign of intelligent life? The answer might not be that life is rare, but that everyone is simply hiding in the shadows to stay safe. In 1983, astronomer David Brin explored a theory known as the Great Silence. He suggested that the reason the universe seems empty is because of the Berserker hypothesis. It is the idea that the galaxy is patrolled by killer probes designed to eliminate any potential rivals before they become a threat. As Brin wrote in his study,
For every 100 or 1,000 or 10,000 sane alien races, there will be one race that is paranoid and xenophobic. They will program their probes to attack any source of modulated electromagnetic radiation, just to be safe. 1983, David Brin. Under this shadow, the Great Silence is not an empty room. It is a dark forest where the only way to survive is to keep your mouth shut and stay out of sight.
To understand the danger, you have to realize how loud we have been. We invented radio only about 130 years ago, and since that moment, our signals have been leaking into space at the speed of light. Imagine an information bubble expanding around Earth. Today, that bubble is 260 light-years wide. In a galaxy that stretches for 100,000 light-years, we are still just a tiny, glowing dot. But the Berserker, this killer probe we talked about, doesn't need to be everywhere. It only needs to catch a single fragment of our broadcast. It is not a biological monster, but a cold, autonomous machine programmed to hunt. Perhaps the signal hasn't reached its sensors yet, or perhaps it is already moving toward us. When Oumuamua drifted in from the direction of the sun, catching us completely off guard, many realized that if it were a predator, we wouldn't have seen it until it was already here.
As we stand on the edge of this cosmic abyss, we must recall the words of Arthur C. Clarke. Clarke was not just a science fiction visionary, he was a radar engineer and a futurist who proposed the very satellite systems we use today. He was a consultant for the most significant scientific projects of his time, and he understood that technology is a double-edged sword. He famously observed that there are two possibilities: either we're alone in the universe or we are not, and both are equally terrifying. If the galaxy is a jungle filled with silent predators, then our attempts to colonize other worlds or send messages into the void might be our final mistake.
Clark noted that while a total defense might be possible in a century or more, the weapons produced along the way would be so terrible that humanity might forget its original goals. So we are left with a chilling dilemma. Should we keep shouting into the dark, or is it time to turn off the lights and hide? In the cosmic silence, the first signal you catch might be the last thing you ever see. For as Clark warned us, any contact with a superior intelligence will be the most unpredictable point in human history. To understand why we are so vulnerable, we must look at our so-called protection. Currently, NASA uses a program called Space Guard to track large threats, but even they admit we are far from safe. Let's look at a story that sounds like a dark fairy tale. About 50,000 years ago, a small asteroid, only 50 meters wide, screamed through our atmosphere. It didn't destroy a continent, but it struck the desert in the United States with such fury that it left a scar we now call the Arizona crater. It is named after the state of Arizona where it landed, and it is so massive that you could fit 12 football fields inside it, or stack 2 statues of Liberty on top of each other and still not reach the rim. Even though this asteroid was small, the energy it released upon impact was equivalent to a massive explosion, as powerful as a modern nuclear bomb, but without the radiation. This single, small asteroid reminds us that while we track the giants, the smaller killers can still slip through our so-called defenses and erase a city in a heartbeat.
The problem isn't just detecting these asteroids, it is the sheer, terrifying physics of the impact. To understand the scale, we have to look at the Tsar Bomba, the most powerful nuclear weapon ever detonated in human history. Tested in 1961, this hydrogen bomb was nearly 3,500 times more powerful than the one dropped on Hiroshima. When it exploded, the flash was visible for over 1,000 kilometers. The mushroom cloud reached 67 kilometers into the sky, and the shock wave was so massive that it traveled around the entire Earth 3 times. It is the absolute limit of human destruction.
Now, take that nightmare and multiply it by 2 million. That was the effect of the Chicxulub asteroid striking the Earth. It hit at 72,000 kilometers per hour, 60 times faster than the speed of sound. Human imagination simply cannot process a blow of that magnitude. This is why one of the most brilliant minds of our time, the theoretical physicist Stephen Hawking, spent his final years sounding the alarm. Hawking, who spent his life unraveling the mysteries of black holes in the origin of the universe, wrote in his final book that the threats to our planet are now too numerous to ignore.
He wasn't just being dramatic. He knew that if we discover a similar threat today, we have no effective way to stop it. We are, quite literally, just waiting for the next roll of the cosmic dice.
All these threats bring us back to the most mysterious visitor of our time, Oumuamua. To understand how strange it was, look at its dimensions. It was roughly 400 meters long, about the size of a massive skyscraper, but only 40 meters wide. Imagine a giant dark needle drifting through the void. When it accelerated away from the sun, it didn't act like a comet. There was no tail, no gas, just a silent, unnatural push.
This anomaly caught the attention of Avi Loeb, one of the top scientists at Harvard University. Loeb isn't just a researcher, he was the longest-serving chair of Harvard's Department of Astronomy and has published hundreds of scientific papers. He suggested that Oumuamua might not be an asteroid at all, but a piece of alien technology, specifically a spent rocket booster or a light sail. If he is right, it means space is filled with what scientists call technosignatures. Simply put, these are technological footprints, signs that someone, somewhere, built something. It's like walking through a forest and finding a discarded plastic bottle. Even if you don't see the person, you know they were there.
But there is a chilling danger hidden in this idea. If Oumuamua is an old rocket part from another world, it means the galaxy is a cosmic graveyard filled with the debris of other civilizations. It raises a haunting question. If their machines are still traveling through the stars, where are the people who built them? Did they simply go quiet, or did they encounter something in the darkness that didn't want to be found?
This mystery leads us back to the theory of John von Neumann. His living machines provide a chilling answer to why we might find technology but no creators. If Oumuamua were indeed a probe, it would have been built to survive the brutal vacuum of space for millions of years. But over such vast timescales, even the most perfect machines would face a critical problem. Survival requires adaptation. Theoretically, just as biological life evolved on Earth, these probes could undergo what scientists call evolutionary variability, changing in ways their creators never intended.
To find the truth, humanity is already planning a response. There is a proposed mission called Project Lyra, which aims to send a spacecraft to catch up with Oumuamua. To intercept this visitor by the year 2050, we must launch our own probe no later than 2030 or 2033. The goal isn't to stop or capture it, but to get close enough to conduct a close-range study and determine its true nature. We need to find out once and for all if we are looking at a natural asteroid or the rusted metallic remains of an ancient explorer.
But as we prepare to chase down Oumuamua, we must be careful what we wish for. If we discover that it is indeed a machine, it confirms that someone else has already mastered the art of interstellar travel. But any civilization capable of sending a probe like this likely sent millions of others. Over eons of travel, even the most perfect code can fail. A simple copying error, a digital mutation, could transform a peaceful scout into a resource-hungry predator. If this has happened before, Oumuamua might not be a friendly greeting, but a warning that the galaxy is filled with mutated AI waiting in the silence.
This dark evolution is the terrifying engine behind the Berserker hypothesis. It suggests that the reason the universe seems dead is because it has been systematically cleaned. Instead of living creators, the stars may be patrolled by autonomous killing machines, berserkers that react to only one thing: the presence of a new, loud civilization. They don't need to be everywhere, they just need to be patient. While we debate whether to meet our neighbors, our radio waves are already washing over nearby stars like a beacon, screaming our location to these silent hunters.
This leads us to the great silence, the haunting fact that despite billions of stars, we haven't heard a single heartbeat from the cosmos. Is it because life is rare, or because everyone else knows better than to speak? Famous astronomer Carl Sagan and his colleague William Neumann argued that any advanced civilization would be forced to act. They believed these societies would actively hunt and destroy any von Neumann probes they found to prevent a galactic catastrophe. 1825, they realized that uncontrolled replication is a threat to the creator and the victim alike. In this dark forest, where a single mistake means extinction, the only way to survive is to be quiet and stay invisible.
We are a young species, barely 130 years into our electronic age. We are like a child shouting in a predatory jungle, unaware that the shadows are watching. As we develop advanced AI to control our future probes, we are creating a digital signal that is impossible to hide. By reaching for this level of technology, we might be triggering the very alarms we fear, announcing our arrival to a galaxy that may not want new neighbors. This is why Stephen Hawking gave us his most famous warning.
The development of full artificial intelligence could spell the end of the human race. 2014, Stephen Hawking.
Ultimately, we must face the reality of our place in the cosmos. In 1990, at the request of astronomer Carl Sagan, the Voyager 1 spacecraft turned its camera back one last time as it left our solar system, 6 billion kilometers away. It captured a photograph of a tiny flickering mote of light suspended in a sunbeam. Sagan called it the pale blue dot. And he realized that our survival depends on whether we can outrun our own curiosity before it draws the attention of something much older and much more dangerous. The universe is silent for a reason, and perhaps for our own sake, we should stop trying to find out why.
As we look at that small dot, we must remember the words Sagan wrote to describe it.
Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. There is, perhaps, no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known.